Dear students, today we're going to talk about functions. We're going to divide this lesson into two parts. First part, we're going to see what is the function machine. This is something which most of you have done when you were still very young, year 7 or Form 1. And in the second part, we're going to see how to write functions and how to use the function notation. So first of all, the function machine. The function machine is made up of three parts, which are the following. We have an input, there is a process, and that process then gives an output. So from an input to a process, from a process to an output. Okay, so let's see what is this process, because the process is the most important part of the function machine. So suppose I have the following. The process is add 5, then multiply by 2. That is my process. Okay, so that's my process. I'm going to place that in a box. So let's say that I input 10. If I input 10, what is going to be my output? So I'm going 10 at 5 becomes 15, then multiply by 2. 15 times 2 is 30. So my output is 30. Okay? Let's see another example. Suppose I input minus 2. What is the output? So let's do it. Minus 2. I'm going to add 5. Minus 2 plus 5 is 3. 3 multiplied by 2 is 6. Instead of numbers, I can also input variables. For example, let's input x. What's going to be my output? So I have x, add 5, that becomes x plus 5, then multiply by 2. So I have x plus 5 and multiplied by 2. I can leave the answer as it is, or I can write down 2x plus 10. It's the same thing. So that is how a function machine works. You start with an input, you end with an output. Sometimes the inverse is also true. So sometimes, instead of giving you an input to find an output, I'll give you the process, I'll give you the output, and you need to go and find the input. Let's make an example of this. So I have my process. Let's write it down, a process. The process this time is multiply by 4, then subtract 10. So that's our process, okay? That's our process. That's what we need to do. So we have, remember, we have the input and we have the output. So this time, let us suppose that our output is 2. What was the input? Let's see. So we have to go from here to here. Now, to work out the input if you are given the output, you need to reverse the operations. So you need to start from back, arrive at the start, and reverse operations. So if I have subtract 10, I have to reverse it to add 10. If I have multiply by 4, then I have to reverse it and work out divide by 4. So let's see what becomes here. So I have 2 as an output. Instead of subtract 10, I have to add 10. So that's 2 plus 10. And instead of multiply by 4, I'm going to work out divide by 4. So that becomes 12 divided by 4, which is equal to 3. Let's find another example. Let's say we have an output of 30. So what will become the input? So I have 30. Instead of subtract 10, I'm going to add 10. Instead of multiply by 4, I'm going to divide by 4. 40 division by 4 is 10. I can also work the same problem using variables. So suppose I have x. So I'm going to first add 10 and then divide by 4. And that will be my input. Okay, so we started this time from the output and we finished in the input. Okay, so that's the function machine. There are various instances in exams where that very function machine comes to good use. Now, how are we going to identify functions? So the function notation. When you use your calculator to input a table in your calculator to input algebra, you know that you press the button mode, normally you choose 3, and your calculator display becomes fx equals, and that is the function notation. So the function notation, when you have a function, you write it as f bracket x. For example, fx equals 2x plus 6. So let's see what we have here, okay, because this is very important. So what do we have here? The fact that it is fx, we know that now that is the function. 2x plus 6 describes the process. So here we have the process. Here we have the input. We have the process and of course the output if we know what is the input. If we had to define this process, alright, if we had to write it down in words, what are we doing to x? We are multiplying by 2, then adding 6. So if we had to write it down in words, it would be multiply by 2, then add 6. So if we had to change all this into a function machine, we would finish with something like this. So we have the input, we have the process, and we have the output. All right? So the input is x. That was the input, x. The process was multiply by 2, then add 6. The result is 2x plus 6. Okay? So this is the function denoted by the function machine. Okay? So that's very important. So how are we going to use now this function? We're going to see some examples. So let's say that if the function is equal to 2x plus 6, find f10. What's happening here? Here I am giving you the input, all right? The input is 10. So f10 would be 2 times 10 plus 6. That gives a result of 26. Okay? Let's see some further examples. Another example, if fx equals x squared plus 3x, find f minus 2. Now, what is the input here? The input is the one in between the brackets, the input is x, here the input is minus 2. So instead of x, we're going to write minus 2. So f minus 2 is going to be equal to minus 2 squared plus 3 times minus 2. All right? All that I have done is I have substituted x with minus 2. So that minus 2 squared is 4. 4 minus 6 is minus 2. So if minus 2 is also minus 2. Let's see another example. If gx equals 2x minus 15, find g10 minus g0. Now, first of all, as we have seen here, instead of f, I have written g. In fact, when we're using functions, we can write any letter instead of f, okay? All the letters of the alphabet can be used. Normally, we write f because f is for functions, but we can also use other letters, as I have done in this example here. So, I know what is gx, the input is x, this is the process. I need to find what is g10, I need to find what is g0, and then I need to subtract. So, g10 is 2 times 10 minus 15, that's equal to 20 minus 15, 5. g0 is 2 times 0 minus 15, and that is equal to 2 times 0 is 0 minus 15. So g10 minus g0 is 5 minus minus 15. Remember that a double negative gives a positive, that gives a result of 20. Now sometimes you are given the output. Let me show you an example. For example, if fx is x squared minus 9, find x when fx is 0. Now what happened here? Here I told you what is fx, I told you what is the process, and I also gave you the output. So if we have to write it down, this is the process, this is the output. And I need to find x. I need to find the input. Alright? That is the input. Okay? I need to find the input. I don't know what is the input. So what do I have here? I know what is the process, and I know what it is equal to. So I know that x squared minus 9 is equal to 0. Solving this equation, x squared is equal to 9, 0 plus 9. So x is that number which when multiplied by itself will give you 9. Remember that we have two possible values there, okay? So it is plus or minus the square root of 9. We have seen this when we've done subject of the formula, okay? So pay attention. So x is equal to plus or minus 3. Try to remember that if you have square on the other side, you should write plus or minus square root. Otherwise, your problem will not be correct. Okay? I'm going to work out another example of this type. So another example, if hx is equal to 2x minus 4, find x if hx is equal to 20. Alright? Same thing, find x means I need to find the input. Okay? So I go the output, and I know what is the process. So the process is equal to the output, is equal to 20. So this is a simple equation, 20 plus 4, which is 24. So x is equal to 24 divided by 2, which gives a value of 12. Okay? So those are what our functions all about. Okay? Now those of you who are sitting for paper B, this is the end of their topic. But those of you who are sitting for paper A, they need to know a small part, which is extra to this. I'm going to continue in this video so that all the topic would have been done. Those of you who are sitting for paper, as I have said, can stop watching this video or can start again from the beginning. So, finding the inverse function. So, to find the inverse function, we need to know, well, what is a function, okay? So please always remember that we have an input, a process, and an output. I'm going to show you two methods, okay? In MathSec, the first method, which I'm going to show you, always came out in the exam. So every time there was a problem on functions in paper A, the examiner always asked questions asking the students to know this method which I'm going to show you. The other method can also be used, but it's normally used when problems are much more complicated. I will show you some examples. So, what we're going to do to find the inverse function, first of all, the notation, how it is written down, okay? The inverse function is written as f inverse fx, okay? We have met that inverse when we're doing sine, cosine, and tangent, okay? Because sine, cosine, and tangent are also functions, and in fact, when we needed to find the angle, we did the inverse sine, inverse function of sine, inverse function of cosine, and inverse function of tangent. Now, what are we going to do? Well, suppose we have, I'm going to work out an example because it's much easier. Suppose we have, if my function is 3x minus 4, find the inverse function. What we're going to do is the following, okay? We're going to describe the process bit by bit. So, the input is x, okay? So, what are we going to do? What's being done to x? X is being multiplied by 3, and then we are subtracting 4 to get our function, which was 3x minus 4. So how are we going to find the inverse? Remember, in the beginning, when we did the function machine, to find the inverse, we start from the output this time. So now x is our output. X is our output. What are we going to do? Inverse of minus 4 is plus 4. Inverse of times 3 is divide by 3. So the inverse function is going to be x plus 4 divide by 3. That is the inverse function, okay? Most of our functions can be easily described by this method, okay? So we first describe the function, then work out its inverse. Let me work out a couple of examples of this type. So for example, I have if fx is 2x plus 5 on 3, find the inverse function. Mela, first of all, we need to describe this. Okay, so we have our input x. What are we doing to x? Mela, we're doing all this. We are multiplying by 2. We are adding by 5. And then we are dividing everything by 3. So it's times 2 plus 5. Then divide by 3. That is our function. Okay, so it's 2x plus 5 on 3. Let's do the inverse now. So we start from x. First thing, we need to multiply by 3. Then we need to subtract 5. Then we need to divide by 2. So we get the inverse function, which is x times 3 minus 5 divided by 2. And that is our inverse function. You have to be a little bit careful if you have squares and roots. Okay, let's do an example. So another example. If fx is x squared plus 4, find the inverse function. So let's describe the function. We have x. What are we doing? We are squaring. Then we are adding 4 to get x squared plus 4. So the inverse function starts from x, subtract 4, and what is the inverse function of square? It is plus or minus square root. Remember that plus or minus is very important. So what do we get? We get x minus 4 plus or minus the square root of. And that is our inverse function. Okay? As I told you during these last exams, O-level, this method is the method that the examiner expects you to know. But sometimes our functions, these functions here, sometimes they are a little bit more difficult, and in that case we have a method which works for when these functions are more difficult. Remember, this was never asked in the exam, okay? So finding the inverse of complex functions. First of all, a complex function is one which can't be easily explained using the function machine method, okay? That one which we have done. So, to do this, we have to follow the following steps. Follow these steps. There are 4 steps, which are the following. Number 1, denote fx by y. Number 2, make x subject of the formula. Number 3, interchange x and y, meaning where there is x, write y, and where is y, write x. And number 4, write f minus 1x inverse function x instead of y. These are the 4 steps. Alright? I'm going to work out one problem on this page to show you exactly what is happening. Okay? So we have an example. Find the inverse function of fx equals 2x plus 3 on 5 minus x. As we can see, that function is much more difficult than the ones before because we have x in the numerator and x in the denominator. So we can't easily explain what's happening there. So we're going to use these 4 steps, okay? So step number 1 was write y, denote fx by y. So y equals 2x plus 3 all over 5 minus x. The second step was make x subject of the formula. Please be careful if you make mistakes here. The problem, of course, will not be correct. So I'm going to make x subject. First, I'm going to cross multiply. So y brackets 5 minus x is equal to x plus 3. We open up brackets. 5y minus xy equals 2x plus 3. I'm going to place x's on one side, the rest on the other side. So 5y minus 3 is 2x plus xy. X, I'm going to take x as a common factor. 5y minus 3 is x into 2 plus y. So x is equal to 5y minus 3 all over 2 plus y. That was the second step. Third step, I'm going to write it here. Third step, instead of x, we write y. Instead of y, we write x. So we have y equals 5x minus 3 all over 2 plus x. And the last step, and that is our answer, the inverse function, instead of y, write f minus 1x, is 5x minus 3 all over 2 plus x. Okay? So those are the 4 steps which you would need to follow to find the inverse function of something which is much more difficult than it was before. Okay? That's all about functions. I'm going to work out another example for you just to make sure that you understood this problem here. Okay? And we'll continue with our lessons next time. So let's find another example, work out another example. So suppose we have if hx equals 3x on x plus 2, find the inverse function, hence find the value of h10 plus h minus 110, right? So we have two steps. First we need to find the inverse function, then work out that problem. So the following will work out. We're going to use the 4 steps. So y equals 3x on x plus 2. So y bracket x plus 2, this is always the same thing. What we're doing, always take out the denominator, multiply it on the other side so that you get one line equation. Open up brackets, xy plus 2y equals 3x. So xy minus 3x equals minus 2y. X into y minus 3 equals 2y minus 2y. So x equals minus 2y on y minus 3. That was the second step. The third step was change y and x. So y equals minus 2x on x minus 3. So the inverse function h minus 1x is equal to minus 2x all over x minus 3. Now that's an important answer result because we're going to use, okay? We're going to use that result. So what is h10? We're going to start from h10. So h10 is 3 times 10 on 10 plus 2. That's 30 on 12, which is 15 on 6. I'm going to leave it as it is. H minus 110 is minus 2 times 10 all over 10 minus 3. That's minus 20 on 7. So h10 plus h minus 110 is 15 on 6 minus 20 on 7. Okay, plus minus is minus, remember. So I'm going to multiply this by 7. I get 105 on 42. Minus I'm going to multiply by 6, 120 on 42, which gives a result of minus 15 on 42, which can further be simplified to minus 5 on 14. And that is our final result. Okay? See you next time. Thanks for your attention.